problem is about similarity measures. So today we talk about this Jacquard similarity here. We said that the Jacquard similarity was equal to, well, we give an example here, but the main formula is that the similarity was equal to between C1 and C2 to the number of elements in the first set intersection the number of elements in the second set divided by the number of elements in the union of the two sets. That is what it's equal to. So we discussed the Jacquard similarity. So problems, let's consider Jacquard similarity of columns of a Boolean matrix. If we use letters A, B, and C, and D for numbers of rows for which A is 1, 1, B is 0, 1, C is 1, 0, and D is 0, 0. So we have same thing here. Then Jacquard similarity of columns is A divided by A plus B plus C. So basically, when they both have a 0, that is not considered. So it's A divided by A plus B plus C. That's one similarity measure that we saw. There's another one. Alternative measure similarity. Is Hamming similarity. which is the fraction of rows in which these columns agree. So what that means is what we have seen here. There are two columns. We look at each row. These two rows are different. The numbers are different here. The numbers are different here. The numbers are the same here. The numbers are the same here. The numbers are the same here. The numbers are different. How many out of the total? The numbers are the same. We have one here, one here, one here. So 3 out of the 5 are the same, or they agree. The fraction on which they agree is 3 out of the 5. That's called Hamming similarity. So let J, X, Y, and H, X, Y, B the Jacquard and Hamming similarities of columns X and Y. So A, 7 points. In terms of A, B, C, and D, give a formula for the Hamming similarity of the columns. These are the definitions of A, B, C, and D, which we have them here as well. Then what is the formula for computing Hamming similarity? Well, we said that it's a fraction. It says it's a fraction of the rows in which these columns agree. And so the total will be rows will be A plus B plus C plus D. And it's a fraction out of the total, which ones do they agree upon? And the ones that are the same, they will agree upon. So if they both have a 1, they will agree. If they both have a 0, they will agree. If one has a 0, one has a 1, they don't agree on those. They have different values. So the ones that they agree are A and D. The B and C are different, so they don't agree on that. So this is the formula. Next, for this problem is points. Indicate if each of the statements below are true or false. If true, show with example. If false, give an explanation why. Statement. The having similarity of x and y can be greater than the Jacquard similarity. Is that true? So having similarities of fraction, we can have 1, 2, 3 here agree. As you can see, 1, 2, 3 here agree. Out of the 5, so 3 over 5 is the having similarity. And the Jacquard similarity is 2 over 5, so it's smaller. So yes, it can be true. So if x is 0, 1 and y is 0, 0 is another example of that. Another true-false statement. X, the having similarity can be equal to the Jacquard similarity. Is that possible? Yes, it's possible. Let's say if x is 1, 1 and y is 1, 1, then both of them would be equal. Both similarities will be equal. And the next statement, having similarity can be less than the Jacquard similarity. And the answer is that it's false. And that's because for having xy to be less than Jacquard xy, then we need an a which is bigger than a plus b plus c. And that is not possible.